Now, ACI basically takes away the way we have been doing networking and focuses on a different aspect of our infrastructure. In today's day and age, let's say I want to provision a new server. Let's say the server is a sales server. If it's a sales server, what do I need to do to provision the server? What I would do is take a look at the appropriate switch that I want to connect it up to. This switch might be a switch that belongs to the server farm. Then I'm going to take a look at, okay, this server needs to be accessed by these particular subnets. So I need to put this in a particular VLAN. So once I attach the port, the server to the port, I'm going to then focus on the VLAN aspect of it. Along the VLAN aspect comes the IP aspect of things. It needs to have the appropriate IP address, appropriate VLAN. I'll get the IP address assigned. It's a server, so it should probably have a static IP address. Let's say static address of 5.51. Then I will go to my firewall, which is again a network device. And over there, permit or provide access to that particular IP. All right. So that my clients, whoever needs to access it, can access it. So all the different things that I need to do to provision this application server that I have, a sales server, maybe a database server, I need to take into consideration networking aspects, VLAN, the IP address, the firewall. All these aspects are known as network aspects or network access. Isn't that true, guys? Aren't these all networking aspects that we need to take into consideration for provisioning an application server? You guys following along? Now, my question to you guys is the network there to provide resources to the users? Are the users there for the network? The whole objective of a network is what? The purpose of a network is to provide what? Provide access to resources used by users, and the users are using what? Applications. But my focus of that network, of those applications, is to basically confine to the network restrictions that I have. I need to make sure my servers are provisioned in a way that they conform to my network architecture. Isn't that true? So if I want to provision a particular server, I need to make sure I'm putting it into the appropriate networking constructs that I have. That might be a VLAN, that might be an IP address, that might be a firewall ACL that I need to conform to. So what they wanted to do is get away from this. This type of infrastructure that we have been using for years is called NCI, Network Centric Infrastructure. And we still do it to this day. Instead of going into this mechanism, what they wanted to do was do it from the perspective of the application. A normal application in today's day and age a typical application in today's day and age is a three-tiered architecture, a three-tiered application. What are the three tiers in it? You have the server, the backend server, the actual data server. You have the client, the PC, using the client application. And then generally what you have is a front-end server that the client makes a connection to. You guys use this type of setup without even realizing that you're doing that. Let me give you an example of that. What's one of the most common applications that you use on the internet? Very, very frequently used application on the internet. Google, isn't that very frequently used to do a lot of your searches? Yeah? Anything that you want to do, let's Google it, right? So if you take a look at an application like Google, you have your client, which is your browser application. You make a connection from the browser to a web server. That is your front-end application server. Okay? And the web server does not have the actual data, which it makes a connection to do your search. That actual search database is inside some type of database server. Agreed? Isn't this a typical application? You guys understand what I'm trying to get to? So those are the three tiers: the client, the front-end server, and this is called the back-end server. Another typical example is your email application. Again, you have your client, you have the front end, and you have the back end. Again, let's use Gmail as an example. Your browser is your client. Again, you don't connect up to your email server, you connect up to a web server that forms the interface, the web interface. And then the web server in turn, when you say, I want to retrieve this email, it gets into your email server to actually display the email on your web server. Agreed? Now, in today's day and age, if I want this type of infrastructure, what I would do is, first of all, I would need to put and assign appropriate IP addresses over here. I would need to put it into the appropriate VLAN at layer 2. Then, in order to control access, I would need to create an ACL on the firewall that reflects the IP address of the database server, giving the front-end server access to the back-end server. I would need to put the client and the web servers into the appropriate VLANs. Again, my clients are trying to access the front-end server. So generally, you'll have a firewall over here. Again, the firewall will control what? Based on an ACL or some type of access control, which front-end server can the client access? And based on that, you would, again, do it based on IP addressing, and based on that, the application works. So our whole focus is on what? Network. That's what they want to get rid of. What we're trying to learn over here is a newer way of doing things, which is called the application centric infrastructure, or ACI, in which the actual networking part of it should be taken care of. you would not need to worry about how networking happens. Your focus should be on how the application, which clients should have access to what front-end servers, which front-end servers you should have access to what back-end servers. So the access between the clients, which clients can access what front-end servers, what front-end servers can access the back-end servers, is what you want to control. In ACI, your networking part of it predominantly is automated. Almost. There's certain things that you need to do up front, but extremely scalable. They take care of the networking, the connectivity. Is taken care of. You need to provide accessibility. You need to provide access. Connectivity is done. How is it done? I'll explain that to you. But I want you guys to understand here, we don't focus, where focus is not too much on the networking part of it. VLANs, IP addressing, putting it into the appropriate VLANs, those things are taken care of. Your focus in ACI is predominantly on which clients can access what front-end servers can access what back-end servers, to provide the application-centric infrastructure. So if a new server needs to be provisioned, all you got to do is put that server where? Into the appropriate container for the back-end server. All the access would automatically be given based on access policies that you would have already defined between the containers. These containers, which are application containers, are known as endpoint groups. EPGs. This is the core component of ACI. Rather than putting the device into a VLAN or assigning IP addresses, put the device into the appropriate EPG, the access will be given. Why? The networking aspect is automated. Understood? I'll show you how it's done, but right now it's a 20,000 feet overview of what we're trying to accomplish. By the end of this ACI class, you will understand that everything is controlled by these components known as EPGs. And these access policies that I'm defining between the EPGs are known as contracts. So the whole story over here is about what? EPGs and contracts. Understood, guys?